Thank you for Richard for putting this in person because I just happened to be in London this week, and I did the same just over a year ago. Happened to be coming down to London to see a show, and happened to be the same show. And in the room, you can probably tell which show it is from T-shirt. It's the Operation Mincemeat. But I thought it's quite nice to actually come and meet people in person rather than just doing things on. Yeah, oh, sorry, Greg.
Excuse me.
Yep.
There's a grey rectangle. I don't know if it's just me. There's a grey rectangle at the top of the desktop. Two of them now, in fact, one large, one small. Is it just me?
No, I think you've got overlays over your over the screenshot. So there's like two windows over the model railway text. That's got rid of the bottom one. Oh, that's a bit better. That's probably what it was.
That better?
Yeah, that's
okay.
better.
Okay, so yeah, so that's how I'm able to do it in person. Unfortunately, it does mean I'm not able to actually bring anything to demonstrate with me. However, you've seen a phone run around the before. But hopefully I'll be able to finish the project and create a YouTube video, and I'll share things like that. And I'll no doubt give you an update on a future call as well. So I'm Stewart Watkiss. I've written 2 books related to the Raspberry Pi, one on electronics and one on programming Pygame Zero. I also did a 12-part series in the Magpie magazine. You may have seen things that was on electronics. What I'm going to talk about here is layout control bus. This is model railway control with a bit of a difference, as I'll explain in a minute. And this is very much a work in progress. I've only recently got it to the point where I'm able to control planes with this. So it is very much talking about more my experience in developing this, my experience in learning about this. So it's a bit of a story behind it rather than presenting a finished product, because it's a long way from that. So the last meeting I actually attended in person, I actually demonstrated a model railway point controller, which is fine because it was designed for my son's layout at the time, which was a bedroom layout, and got wiring all over the layout. But since then, I joined MERC, Model Electronics Railway Group, and they're very much into creating smaller layouts, things that you can take along to a display or something like that. And so I got working on creating a demo of my project that was portable. And then I sort of started to come across some of the problems that you experience with those. I'll come on to that in a minute, but basically, it was about how you wire across the layout and creating so much cabling that it becomes no longer portable. So that's where layout control bus comes in. Move on. I'm in the wrong place. Oh, there we go. So there's a QR code there if you want to get some more information. But yeah, so what I'm going to go for is about the layout control bus, about why. I'm going to talk about what CBus is. Well, probably better, rather than explain it now. How I learned the protocol. Some problems I encountered. I tried to do this tool in Python. To get it working, I've had to use a bit of C and Python. I may have just cracked getting back to Python, but maybe or maybe not, but I'll find out. And that's really going to be what my what's next is, telling you about that. So this is a portable layout. This is the underside of the layout. And this is very much the emphasis of starting to cable it up. And this is actually the board I was presented about my previous thing. And basically from this, you've got a set of cables going to all the different points, and there's a lot missing on here. But this board is designed for two parts. And basically, if I have to wire this all over here, then you talk about a huge mass of cabling, and you've got loads and loads of connectors. So the idea is just to literally have two sets of connectors, and that you do that by creating a layout control bus. And the one we're talking about here is CBus, and that's specifically because it's used by Merck, which is a group I joined, and that's the one that they're sticking with, and they create lots of kits based around those. And CBus is based on technology known as CAN-bus. And the reason there's a picture of a car here and a train is because it is used throughout industry. The CAN-bus is used almost certainly, your car uses CAN-bus. Most trains these days use CAN-bus. Most any form of transport, to be honest, planes, various things, all based around CAN-bus. And the idea is it's a technology that allows us to reduce that amount of wiring. So instead of, for instance, a car, you think of the number of devices you've got in car. Even if you just look at left indicator, right indicator, brake light, fog light, things like that. Each time you had one of those, on the old days, like in the 70s, then you would have had an individual cable for each of those. Nowadays, that's replaced by the CAN-bus. But obviously on a car, that's very important that those signals are received immediately. So it is a very robust technology, very fast and very reliable. Also things like prioritization. It was created by Bosch, originally designed CAN-bus, but it's pretty much used widely around the industry. The CBus came in was a group of people in Merck that decided, well, they were wanting to create a layout control bus, and they called it CBus because it's based on CAN-bus. And then VLCB is perhaps the next generation of CBus. And really, it's CBus, but with more flexibility. Just mention that because a lot of my code refers to VLCB, which is, it really is just CBus. They're the same thing, but I'm hoping to add some of that additional functionality in the future. So where do I start? I knew about CBus, but didn't really know how it implements. So I've got all these modules, took them all together, and there's quite common software called JMRI that people use. The Java Model Railroad interface, it's American. This is open source and very popular. But I'm not get something, put it together and let it work. I'm more of a hands-on. I wanted to develop it myself. So this was more useful. So this is MMC server. This is a device that's designed for configuring these modules. For each of the modules, they need to be given addresses. They need to know how to use. You need a computer to configure them beforehand. So this was a really useful piece of software because you can sort of, when you're configuring it, you can see some of the messages going across. So it gave me a little bit of an idea about how it was controlling. This is the initial setup. So This is the DCC controller. This is the CAN USB 4, which is how you connect it to the Raspberry Pi. And then I've got a controller as well. And basically, it allows, so this is what I'm programming, how we connect this, and then that's going to talk to all the devices. But it listens to everything that's going on the network. So I could see all the messages going to and from the devices. The particular point at which I'm seeing from the Raspberry Pi, so I'm using a Raspberry Pi 400 here, connecting to here. So this CAN USB 4 is the point I'm looking at, specifically how you go from here to here. The important thing about this is that it's basically a USB connection. The USB means it's serial, basically. So basically, I'm looking at using basically UART connection, basic serial, how to connect to and from these devices. So it just so happens, unrelated, I'd been looking at, well, a different project. How can I see the messages that are going on between those? So use packet sniffing. So this is Wireshark. And this is a Wireshark, if you've not come across it before, is mostly used for watching Ethernet traffic. You can use it to monitor your local network, and you can see all the packets going to and from. If you direct that instead to your USB, you can see the USB connection. That's it. I did skip over a slide there. That was how I was able to see the package. I could go back and just use the back button, just go back to the previous slide that I just skipped over. It felt like it's out of order. So I was able to packet sniff, but I needed to understand what I was looking at, really. You can see packets, you could take them and you could do replay. So I could take packets. So I could use that handheld controller. I could get it to move a loco, and I could copy and paste what it did and replay it. But it wasn't really enough to understand it. But that code I showed before, the MMC server, it's open source. So I could see the source code to it. But again, that wasn't really enough information on its own. But what was really useful was seeing the operating codes, these opcodes, which then, when I was sniffing, I could, I'm not sure. Oh. So if I, group out of order again, but so these are the opcodes here, and I just recognise these by, I knew what sort of opcode it was talking. So I could see that this has got 57. I knew that's a nerd read back all sort of events. The B6, CNN, and I could just look at these from looking at the source code of the software and what I was doing, actually doing some sniffing. But the problem is, I could see other bits as well. I could recognize my loco address in there. I could recognize other bits, but I couldn't quite make it all out. And the reason being is that some of these are not just dedicated fields. Some of them overlap with other things. They share information. Some have got a certain bit that means something. So I wasn't able to fully understand it. Let's go back to the previous slide again. I'm taking these a little bit out of order. And then finally, I found this one document, which was really, really useful, which actually explains the protocol. And it's called the Developer's Guide to CBus. But one of the things about basically is that because Merg does everything, it's a membership group, all the forums and members only. They don't get picked up by the search engines very well. So although this is publicly available on the internet, it's not massively ranked, and it's not that easy to find if you use the search engine. So that's kind of why I didn't find it. Eventually, looking through the forums, I was able to find this document, and now I know where it is and what it's called. It's easy to find. And this goes through what each of those codes do and how that string of information is made up. Now, the important thing is that any of those three on their own was not enough. Perhaps I could have got away with knowing two of those bits of information and trying to build the other up. But once I'd got all three, I was able to do it, because I don't think I would have gone from this either. And this is a very technical document, and it makes a lot of assumptions about you knowing other things. So that's kind of the story that I was going through, is that learning these things is about. It feels like a bit of detective work. You're finding different sources of information and then bringing them all together. It's just like a light bulb moment. It clicks. Yeah, I understand it now. I can now start developing my own code. So they're the sort of codes we're looking at, and this is actually some of that. So this is the first part of the code that I wrote. So I wanted to do this in Python. It's my preferred programming language by far. Ever since I've coded in lots of different languages, but ever since I've used Python, I love the way it feels so well organized, and the object-oriented code is easy to create. Anyway, so I started by, and this was a very tedious job, taking every single one of those opcodes, and there's pages and pages of them, and creating my own structure, so that when I was learning them, instead of having to look them up, I could have my code, monitor the CAN-bus, monitor the CBus. Every time it saw something, it could convert it and make it into a useful string, so I could understand what's going on. Then I created my own library that would parse it. So basically, this is parse the input, will go through, decode them from so serial, so from serial byte data into a string, and then it would just look, and it would start looking at these, and then based on these, I knew what format it was supposed to be that could decode each value. And this is the real part where I was like, yeah, I'm going to be able to do this. And then this was the first iteration of a bit of the GUI code that I created. Basically, it's the console, and it's literally just looking up. So it's got timestamps, got those codes that it's seen on the bus. CAN ID is each device on the CAN bus has to have its own ID, and it's allocated. So some of them are pre-programmed. 127 is DCC controller. 60 is my USB, and then the rest are just allocated as they're seen on the bus. That's the code interpreted, and that's each of the fields that were extracted from that string. That's each of the different fields, so that I can understand finally what it's doing. So to develop my application, these are sort of my requirements, and these sort of like tie into some of the issues I came across. So basically, I wanted a GUI application. I've been doing a lot recently using PySide, Python GUI framework, so that was like my first choice. I want to be able to provide an API. So like my previous project, as much as I want to use a Raspberry Pi with a screen, I also want to be able to call it from other devices as well. So I want an API that maybe my mobile phone can connect to. I also want to be able to do some basic automation. Main things are I want to be able to say, instead of calling an individual thing, I want to be able to say, go to this station, we'll set it off, and when it gets there, it's going to stop. And it needs to be near real time. there's a difference between real time and near real time in that real time needs a dedicated real time operating system and you need to guarantee it. As long as when I press stop, that train stops and doesn't roll off the end or press into another loco, that's what I mean by near real. So these were the things that were going through my mind. Well, how do I create this into software? And this, yeah, these are my 4 iterations. Right, so there's a reveal on this. The first one, so take the first one. I did CBus control within the GUI application. So I created one big GUI application. That GUI application included PySerial, would talk to the serial bus. First tried threading, and that was a no-no. So the reason being is that Python threading, really good for creating GUI applications. I've used it before, but relies on the Python global interpreter loss. If you're not aware of that, then it's a deal. It is a crucial part of Python. It was created to ensure that non-multiprocessing aware software doesn't have issues when running the Python. It means that only one thread is able to run at a time. It's just threading, but only on one processor at a time. So you'll only ever use one core of the thing. And because the serial, they spend a lot of time just checking and checking, it was just like, it was no go. And again, I then tried, well, let's try multiprocessing instead and kicking off several processors. And that didn't work either. Started to get loads of issues with trying to keep them in sync and things like that. So then I created using separating the server, having a server piece of code and my GUI application, 2 separate applications, both in Python, and then talking to each other using a 0 message queue. And I put cross because it didn't really work, but that is actually how I got it first to work, and I was able to see those messages. But I wasn't really getting that real-time response that I was wanting. And this was before I started controlling the locos. And those locos, you have to start sending people live to the locos, otherwise you're going to lose your connection every 4 seconds. It doesn't sound very, 4 seconds for a computer, it's almost forever. But when you're talking about trying to keep up with this PySerial and run all these separate processes at the same time, said about 4 or 5 different processes at the time, and that wasn't working. So the one I did get working was to use C and write a really small C server that used lib micro TCP. And all it does is it holds the serial, constantly getting activation. Whenever it's got new messages, it's just testing it out. And then using lib micro HTTP provides you a very basic web interface, web server, and it sends things. It's working, but this is the reason I'm not a big fan of C. Is that every now and again it throws just a segment fault and it just crashes. Now I know it's my code. I know it's because I'm not perhaps allocating the right memory or I'm losing a pointer or something like that. But although C was a programming language I first learned programming on, really did most of my initial programming on C. After moved by Python, going back to doing more than a small piece of code in C is painful in terms of allocating memory, keeping track of that memory. And the other thing is I didn't really want this to be a combination of different codes. I want it to be something that somebody can install by just install these Python libraries and then run it, or install the C code and then run it, but not. You have to install these C libraries, you have to compile this C part, you have to install these Python libraries. It just felt like it's a bit of a mess and a bit of a box. So my next step, and this is jumping apart to what I'm looking at, is using Python and Flask. Now, vast majority of my projects actually use Python and Flask, but I kind of dismissed it initially on this, and then I was more concentrating on code to touch the GUI, and that the API was going to be a add-on separate bit. But coming back to this, thinking, well, actually, my default approach that I would normally take in creating a project is actually probably the best approach than all this fancy stuff I was going to do. Still needing to use that multiprocessing within the server part. So I'll be using threading in the GUI application, but multiprocessing in the Flask server so that it can talk to the USB and to the handle the web request at the same time. And this is how far I've got so far. So there's that console, which is just another window that you can get dismissed if you want, but it allows me to do the debugging. And then this will be my final application on the background, partly hidden because there's nothing there. It's white screen at the moment. So the idea is this white area would have pictures of your layout, of your points and things like that. So I click on and solve. And then the node part has got its learning process, it learns all the modules, and it just lists all the modules and allows you to send signals to them. But this is the main bit, and this is to be able to control a loco. You basically fill out the loco, you've got forward and reverse, you've got a dial, control the speed, it shows you the speed it's running, got stop, and then functions are controlled here. Functions particularly relevant if you're using sound locos. All mine are. So you can send steam whistle sounds and whatever by turning functions on and off. It's not a. There's other ways of creating state. I'm not sure whether this will be my final one, but it was basically a way of using the standard Python components to be able to build an interface that I could just then add all the functionality that I need to be able to test. And then in future, I'll think about whether I'll just enhance this or design something completely different. I sometimes do that with my projects. So I'm like, well, you know, and I think that's one of the important things when you're doing a project is to think, is this working? Is this doing what I want to do? Or am I going down a dead end? You need to make that decision at the right point if you don't want to turn away too quickly. But you also want to, so you want to give it a proper chance, but don't be frightened of moving back and thinking, actually, if I redesign this, even if it's thrown away to code, I'll get what I'm trying to achieve out of it rather than spending my time doing something that's not. So, brings me on to my future plans. So, work on that server and an API. At the moment, the API is very basic. It's only got two commands. One is send a command, and one is read all the data that you've got stored. Basically, the server takes the information, stores it in a big buffer, and then supplies that thing at the moment. To do an API, I potentially need to expand that. I've not really decided because at the moment, anything that uses that model needs to keep track of every module on the board and sees what and therefore has to read every single message that's on that CBus. So that means that API would have to send it out to all the different devices. Whereas if I could have the server aware of CBus, I wouldn't need to do that. And that was one of the things I was going to do earlier. I'm not sure whether I'm doing that or not. Additive features of the loco, basically, I'm partway through it. I've got it going backwards, forwards, controlling the speed. I haven't put any of that code behind the function bus. But really, it literally is only a case of adding that code. I know what I'm doing. It's quite straightforward. The automation, as I said, I want to be able to extend it off the state and have it stop automatically. So that means adding small modules with some going on track detection or some infrared detection. Add that graphical layout and then write up our YouTube videos. And one of the things I was saying to Richard before. So got a YouTube channel. Create quite a lot of videos until a few months ago, and it's gone very quiet. The reason being is because this and two projects I've been doing have been taking a lot of time. And although there's plenty of things I could have talked about what I've done so far, when I'm doing the project, I just want to spend my time working on that project and progressing that project, rather than doing the YouTube videos. Even like some of the YouTube videos takes hours and hours of work just to put together. So I'll be doing all that in future. I'm also likely to do a talk and a real demonstration in July at the Merg group in the West Midlands. If anyone's in that area and interested in actually seeing that, and then to carry on and develop that as a project. I think that's for the last slide. That's I've got that. Yeah. So yeah, over to any questions, any comments, any ideas.
I've got a couple of questions. The first one, can you hear me okay?
Yeah, that's fine.
Okay, so the CBus that you're using, is that really just CAN bus with some application level abstractions put on top of it?
Pretty much. Yeah, I think it's a simplified version of CAN bus. They haven't fully implemented the whole CAN bus protocol, but it is, it's CAN bus, and they've just said these are the messages we're going to have, which you lay out, which is specific to model railways. So it's like DC controller has a certain code and things like that. But yeah, it is on the actual thing. So it's at an electronic level, it's using the same kits that are fitted inside the cars that talk to CAN bus.
Yeah, and the second question I've got, which is a bit more off piece, really. You said that Python doesn't do threading, or it sounded like you said Python doesn't do threading very well. Now, I've never written in Python, so it's probably just another excuse for me not to use it. But is that a problem with? Is that a shortfall of Python, or is it just to do with the OS/hardware that you're running it on? That it sounds like you said that it's single threaded and it does time division multiplexes the code, so it doesn't really run as true multi-threaded.
Pretty much, yeah. If you just Google for Python and GIL, global interpreter lock, you'll find that is potentially a general thing with Python. It doesn't affect multiprocessing. So you've got two ways you can do multiprocessing. You can do threading, or you can do true multiprocessing. The threading, by having a single, you've got single interpreter that's controlling all the individual threads, then that hits that problem. If you're using through Python multiprocessing, then you get multiple versions of the interpreter, and it isn't affected by that. There is, in the pipeline, a potential solution. It's been a problem since Python was created years and years ago. And very recently, as in within the last few months, because people have proposed solutions to it, and they've always been dismissed. But there's one that's generally accepted as a real solution. How long that's going to take before that actually becomes part of the Python interpreter, I don't know, but yeah, at the moment, threading will only use a single core, even though you're spinning up multiple threads.
So just DIL, is it? Yeah.
GIL, Golf India Lima, Global Interface Lock. No, Global Interpreter Lock.
Got it. Thank you.
Won't hear you. Do you want to switch to that microphone? I'll repeat that. Yeah. Okay, so Richard's going to have to press I'll just repeat that. Yeah, so the question is, how does CBus address the different devices? So actually within, and I just didn't cover this at all because I thought it's sort of going a bit more detail, but there's actually two ways you can do it. One is known as slim mode, and the other is known as slim mode. One is simplified logic, and you can put dip switches onto the devices, and you can put them in a learn mode, and you can program them that way. And then the other way is the full slim mode, which is where you need a computer to actually coordinate them, and they basically notify themselves as being available, and they're just allocated the next address initially, and then it stores then you program it with an address, which is done through that MMC server, which is the whole point of that MMC server is to then program your addresses for each of the things. So each device, you program an individual address. So that's all done through the CBus. It's all done through your own code, and one of the extensions of VLCB is that you can store that information on the actual module. These modules are smart. They're not dumb modules. They're generally PIC controllers rather than microcontrollers, but you can program them to broadcast. This is what I do, and this is what I'm capable of. But using the standard CBus at the moment, your server needs to keep track of that, you can program the devices. It gets quite complicated if you get to this thing, but you can program the modules so they're aware of each module. But it's all just down to a number level. So you generally start number 300. So my first module is going to come online. I'm going to tell it that your module 300, and then going to program each event it can do. So if it's got a switch, I'll say event number 1 is on switch being toggled on, and then it's producer consumer. So that would become a producer. Then any device that you want to be able to respond to that switch, you'll say you will consume number 300, event 1, and do whatever logic. So it's like you can program them that way. And you can do your whole layout, and you just need your computer to program them initially, and then you can get rid of the computer. But what I want to do is actually have the computer as being a master controller, consuming all these events, and then sending out new events to all the other devices. Okay. Yeah, so the question was about automation. Is it going to be like yeah, I was making out maybe a bit both. So is it going to I'm thinking along the lines of if then do that, if I don't got the IFTT, if they do then that's it. IFTTT or whatever it is. So that's the protocol where you say if certain conditions are met, do something like that. So I was thinking basically having a simple interface that does that as part of the automation. I'm also thinking about maybe on the GUI, you would have I click on the loco and say send to. There's only a limited amount of automation you can do because unless you go to the nth degree, you've only got a little bit of awareness of locos and where they are on the track. Now, some people have done this, and some people have split every bit of their track into block sections and got track detection on those. And you can do this. You could, if you've got the time and effort, you can do nth degree. Actually, that's one of the things I was thinking potentially a camera and doing maybe some AI, but that would be a long way down the pipeline. But for me, I'm thinking it would be more straightforward. And I'm particularly thinking there's on my layout, it's quite basic layout. I'm just doing a station at the moment. It would be there'd be platforms, and it'd say if the train the sensor triggers at this platform, stop, and that's all it's going to do. And same with sending it into the engine shed. The main one being the engine shed, because once it goes in there, you can't see how far it's gone in. So the idea is once it goes in the engine shed, it will get to the end, an infrared detector will pick it up, and then it'll stop the loco. Yeah. Question?
I'm not sure if it's the same for anybody else, but the two boxes or windows that you've put over the actual future plans window, it just causes black screens on the remote ends, black boxes on the remote ends.
I think, yeah,
Yeah,
that's
that's basically covered the screen.
yeah, I don't know whether you can hear Richard. So Richard just put that up so that I can see people's faces on the screens and I can see if there's any text in the chat rather than showing the whole screen. But yeah. Okay. So yeah, so the question was, what am I looking forward to now that I've learned the protocol? I guess one of those things was that I learning about the protocol for me was a big challenge, and I actually enjoyed that. I mean, I enjoy just tapping out code. Yeah, I enjoy that, but and it can get frustrating as well. I just like, oh, throw this out the window. I've really had enough. But I actually found the process of understanding it challenging, and I actually really enjoyed that aspect of it. Now that I've got to this point, I think there's two aspects. One is, yeah, just adding the code to make it work, and it's not necessarily as rewarding, but it also feels like it's achieving something when I'm getting like when I've got 8% of the code readers created to do that. It feels like I'm progressing, and I get a bit of a buzz out of that as well. But I also like continue to challenge myself. So my next challenge is going to be about creating that GUI, whether I'm happy with that interface or whether I want to say, and what I'm going to do about the clicks. And I thought I did it before on my old project, so I could just take that code and dump it on. But I'm kind of like, well, I've learned a bit more about Python. So maybe there's a better way of doing it. No. For me, this is a bit of a journey for me, and I'm always I just love learning all these new things and applying them, and then the accomplishment of doing that. Yeah. So the next question was about when making that decision about whether to scrap that code and or keep on working on it. And yeah, rewriting it. Yeah. I tend to be quite bad at making that decision until I've hit a real roadblock that I feel like I can't get past. On the first iteration, it was just trying to keep track of all the different processes, and I just saw that they were not talking to each other. I was like, oh, there must be a better way of doing it, and that went through my head. Then for the second one, where I was before I went to the C one, and I was just like, I've got this point, I can see the messages, but they're not coming fast enough, and I know they needed to be a lot faster because I've got this next stage coming up. And so basically, at that point, I hadn't started controlling the load code. I'd just been looking at controlling points in the other module. And when I started looking at the protocol for the modules, and I started watching it on Wireshark and saw how much messages were coming through, and knowing I had to then generate all those messages, I thought, no, I need another probe. That was my decision. The C still feels like it's a bit of a temporary thing, but it's only a fairly short bit of code, and it was a much case of I don't want it to stall at this point. I don't want to get too frustrated. Let me just get something that works as a proof of concept. That's why I went to that, and then I think for me, I think I tend to go as far as I can, and there must be something pretty bad for me to go back and. Well, let's say now I have done it on other projects as well. There's sometimes go back and think this isn't working, or it's going to take more effort to fix than it is to go back. Okay, yeah, CJ. It's one of the things. I think it's a very good question that sometimes it's being able to see that for yourself. And yeah, so Richard just made that comment about when GUI is that sometimes you put your buttons, it looks good, but again, it's work. I've literally been going through that stage myself. So a few years ago, I've created GUI applications. I've used Python a long time ago. I created one for part of work. It was a dashboard that shows things, but not really got that into it. And then it just so happens there's another project I'm working on, which is purely the GUI software application. And that has been really a proper effort to learn the GUI itself. And this is why Python was always going to be in it, because that's Python. And I think I've learned so much about it, and there are so much nuances about creating GUI applications, and it is really a big, steep learning curve. I think going into GUI, I mean, I've got it from my other project went from 2,000 lines of code to over 6,000 lines of code by adding that GUI onto the state front software. So. I did do that. I've done code reuse from other projects today, and I find it saves you reinventing the wheel sometimes. I think, and especially so when I've gone to this Fast server, you go into my GitHub page, so that link will take you to my website, which has got the GitHub page on if you want to go and look at the code. If you like to look at the code for the Flash server is the Pixel server, it's called, which is I used to create NeoPixels. I created that years and years ago, and literally I copied and pasted a big chunk of that code and then started developing on that. I felt, but I must say I'd forgotten a lot of what I'd done. Particularly, I'd done some blueprint template stuff. I think I've forgotten ever done that. And I'm having to learn blueprint templates all over again because it wasn't my original style of coding. But I'd done it for that project, and because I've copied and pasted that code, that's what I'm looking at. So yeah, code reuse is something I certainly do to a reasonable extent.